Welcome to the Bourns Magnetics Overview Training Module. The objective of this module is to introduce Bourns Magnetics product lines, provide an overview of inductor products, discuss featured products and SMD power inductors, and showcase product selection and design tools on the Bourns website, www.bourns.com. Bourns power inductors provide unsurpassed performance in buck, boost, and many other topologies of DC to DC power converter applications. Features include low DC resistance, ideal for mobile electronic devices operated at prolonged battery life. Ferrite core helps achieve very low core loss at high frequency. High ripple current helps avoid unnecessary power consumption and excessive temperature rise. High saturation current characteristic helps maintain sufficient inductance at high levels of peak current. And magnetically shielded construction helps to ensure that low-level radiation will not interfere with sensitive circuits or nearby ICs. Bourns SMD inductors include signal line common mode chokes, multi-layer wire-wound chip inductors, and non-shielded, semi-shielded, shielded high-current power inductor models. The power chokes category, which consists of non-shielded, semi-shielded, shielded high-current power inductor series, are featured products for the Bourns Magnetics product line. Bourns power inductors are designed to combat levels of conductive electromagnetic interference, EMI, at frequencies from a low kilohertz range to a few hundred megahertz range, either with a single inductor or multiple IC components for enhanced attenuation. Shielded construction and the high self-resonant frequency of these inductors help to maintain a steady minimum loss of impedance over a wide frequency range. Bourns surface mount power inductors are featured magnetics products. This line of products includes 25 series of non-shielded, 83 series of shielded, and 110 series of automotive-grade inductors with over 3,000 individual part numbers. Select Bourns SMD power inductors from the get-go of your design. You will most likely find an inductor well suited for the application. Bourns manufactures wide varieties of inductor products offering axial leads, radial leads, toroids, and common mode chokes in through-hole in both standard packaging for lower current applications and higher current packaging for higher power applications. The SDR models are low-cost, non-shielded SMD power inductors designed for applications where high saturation currents are essential and radiation is not a primary concern. SDR models offer footprints from 3 by 3 millimeters to 22 by 22 millimeters with inductance values up to 15,000 microhenries and rated current to 16 amps. The SRR and SRU models are shielded SMD power inductors featuring low DC resistance for low power dissipation and magnetically shielded construction for low radiation. These inductors are particularly attractive for applications where a low noise environment and extended battery life are essential. The SRR and SRU models offer footprints from 2.8 to 2.8 millimeters to 18 by 18 millimeters with inductance values up to 15,000 microhenries and rated current to 20 amps. In addition to shielded construction, low DC resistance, and a large variety of size selections, the octagonal shape SRU models are recommended for their identical footprint design with up to 4 profile variations. For example, a designer starts his design with the model SRU 1048 series, a 10 mm footprint for a 4.8 mm tall component. If a subsequent design change is required to lower the component's height, the designer can switch to the model SRU 1028 series in the same footprint with a 2.8 mm tall inductor without respinning the board. For other upgrade requirements, a higher rated current inductor, model SRU 1063 series, a 6.3 mm tall component can be selected. Again, the footprint remains unchanged. Instead of using a conventional ferrite shield, the magnetic shield of the semi-shielded inductor series utilizes epoxy ferrite powder mixture resin. This compound is applied to the perimeter of the inductor, which completely envelops the winding. As a result, these semi-shielded inductors provide effective magnetic shielding while emitting lower radiation compared to non-shielded inductors. In addition, the models offer a reduced footprint and cost savings to comparably sized conventional ferrite shield inductors. In essence, the semi-shielded series is designed to bridge the application gap of non-shielded to shielded inductors. The SRN semi-shielded models offer moderate shielding effectiveness compared to the non-shielded series and provide cost savings compared to the shielded series. 2 by 1.6 to 10 by 10 millimeter footprints are available, with an inductance selection range from 0.33 to 680 microhenries. Rated current is up to 12 amps. Several series are manufactured in 1 to 1.2 millimeter heights, ideal for low-profile electronic device designs. SRP models are shielded SMD power inductors featuring an iron powder core. The iron powder compound is compressed to encapsulate the coil winding at center. Available footprints are from 2 by 1.6 millimeter to 23 by 23 millimeters, with inductance values up to 100 microhenries and rated heat rise current up to 70 amps. The rated temperature is up to 155 degrees Celsius. 4 series are manufactured in 1 and 12.6 millimeter heights, which are ideal for low-profile electronic device designs. One of the key features of the iron powder core is the high current handling capability. Here we're comparing the DC current characteristic of the iron powder core model SRP7028A-2R2M and a ferrite core model SRR7032-2R2M inductor. Both inductors have a similar footprint and height. As DC current rises, the inductance of the iron powder core SRP drops at a much slower rate than the ferrite core SRR inductor. Bourns has developed a special selection of reliable and high-quality inductor series suitable for the harsh automotive application environment. These inductors are qualified to meet the AEC Q200 stress test qualification for passive components. These models are available in non-shielded, shielded, and iron powder core high-current designs, which offer footprints from 2 by 2.16 to 23 by 23 millimeters with an inductance range from 0.1 to 4,000 microhenries and rated currents up to 70 amps. Although these AEC Q200 compliant automotive-grade inductor series are primarily designed for automotive electronics applications, they are also well suited for consumer, industrial, medical, low to medium risk, telecom, and other critical applications where higher inductor reliability is required. On the next 3 slides, we're going to compare some key characteristics of ferrite core non-shielded SDR, semi-shielded SRN, shielded SRR-SRU, and iron powder core high-current SRP series inductors. Inductance of the magnetic core inductor will reduce under DC bias. An inductor's ability to preserve its value under such conditions is measured by its saturation current characteristic. Due to the effect of a large air gap, the model SDR series maintains the highest inductance during the initial rise of DC current. The model SRR-SRU series with the smallest air gap results in the largest inductance reduction. The inductance drop rate of the model SRN series under DC current falls between the SDR and SRR-SRU series. The iron powder core model SRP series, developed with distributed air gap property, demonstrates the best inductance retention rate at a higher DC current level. The coupling factor is another important parameter to characterize an inductor's magnetic flux radiation level. Coupling factors of similar size and inductance for the model SDR, SRN, SRR, and SRP series are recorded. Non-shielded inductor pairs reveal the highest coupling factor in about 23%. Semi-shielded inductors come in second with 17%, shielded inductors with 0.4%, and the molded construction iron powder core SRP conductors registered the lowest 0.3% coupling factor. Ferrite and iron powder core inductors perform much differently under DC current at different temperature levels. At 125 degrees Celsius, the inductance of a ferrite core inductor can decrease dramatically from 25 degrees Celsius under the same DC current level. However, the inductance of an iron powder core inductor under DC current is virtually unaffected by temperature changes. The Bourns website offers several useful tools, including a parametric search that conveniently allows users to locate inductors. By entering the required inductance and rated current, and DCR if desired, a list of matched part numbers are displayed. Users can select the datasheet PDF to review the construction and mechanical features of inductors to further fine-tune the selection. Users can also access the Bourns website for cross-reference search assistance. By entering the competitor's part number or prefix of the series, the Bourns comparable part number or series will be displayed, if a cross is available. Bourns offers inductor 3D drawings for mechanical layout, S parameters, SPICE library data, and equivalent circuits for circuit design simulations. Please visit the Bourns website to download these design files. Bourns offers a wide variety of product design kits for your sample builds and component evaluations. 14 chip inductor and 15 SMD power inductor design kits are available for distribution.